Camera?
Hello.
No.
Should I start or have you not gone live?
Okay. Are you hearing me?
Yes, I'm Maimoon. Yes.
Okay. And now let's move on today with Adobe AI powered the fraud detection. Here is Maimoon Saleem, senior design manager at Amazon, who will show us how predictive analytics and the deep learning are being used to fight fraud in real time. And let's go and happy learning. Hello, you can start.
Perfect. Thank you, Akram. Hi, everyone. I hope you can see my screen with the title of the presentation, basically AI-powered fraud detection for payments and transactions. I am Maimoon Saleem, a senior program manager at Amazon. I'm excited to talk about a topic that sits at the intersection of AI, risk, and real-world impact, which is fraud detection in digital payments. As financial payments scale and digital payments become ubiquitous, fraudsters are evolving just as fast, sometimes even faster. So today I will walk you through how AI is stepping up as the frontline defense layer in this ever-escalating arms race. A quick introduction about myself. I think introduction is always due. I'm a data-driven operations and program manager with a background in analytics, automation, and digital transformation. I have worked across both e-commerce and the automotive industries, and I currently lead programs at Amazon focusing on operational excellence, tech-driven innovation, and fraud mitigation. I have also been fortunate enough to receive scholarships in the past from institutions like Cambridge University and Dortmund University, which helped shape my research mindset and technical foundation. Coming to the topic at hand, let's start by looking at why fraud detection is such a pressing issue. Digital payments are booming from e-commerce to fintech to peer-to-peer transfers. But with that growth comes a darker side as well. Fraudsters are exploiting system vulnerabilities with ever more sophisticated tactics, often using AI themselves. Traditional rule-based methods simply can't keep up anymore. Financial institutions are recognizing the urgent need for real-time AI-powered detection systems. And this just isn't about losing money through fraud. The stakes are even higher. The reason being businesses face reputational damage, compliance failures, and even regulatory penalties if fraud isn't caught fast enough. So the stakes are high in the hunt for detecting fraud in transactions. Coming to more on numbers, because I'm a person of numbers. So coming to the numbers and what exactly is the size of this market. So the market itself is $48 billion. So that's the total amount of payment fraud that happened last year, according to a research by Juniper Research. And that's not just a number. That's money siphoned from customer accounts, merchants, fintech platforms, banks, and government systems. And I think it's very easy to get lost into the numbers of 48 billion. But just to give you a measure, this is more than the annual GDP of 100 countries. So imagine an entire economy or even part of the world gone simply to fraud. And the most troubling part, the number has been steadily increasing every year, even as security systems improve. That would tell us that fraudsters over time are innovating faster than some systems can respond. And another interesting statistic is 85% of fraud attempts now use AI-based methods, including deepfakes, which is used in identity theft and know your customer evasion, synthetic identities, where fraudsters blend real and fake data to impersonate or create ghost customers and perform transactions and are often held by criminals as well. Then there is always this AI-written phishing emails and SMS messages we all have gotten at some point in our lives, or especially recently, which basically mimic human writing styles. What this tells us is that fraud is no longer an amateur game. It's industrialized, and also it's algorithmically optimized. So if you are not using AI and if you're running a business, you are facing attackers who are using AI to create it. That's a very dangerous asymmetry that exists. And that story doesn't end there. Another critical insight is that for every $1 of fraud that happens, actually costs businesses $3.6. And how does that happen? So firstly, chargebacks. This is when companies or businesses have to refund money. Plus, there are payment fees from payment processors, which are the middle parties looking after transactions. The other is investigation costs, so employee hours, tools, and legal compliance. So that all costs significant amounts of money. And additionally, customer churn. So users lose trust and abandon your platform. So I think we live in a day and age of TikTok and influencers and whatnot. So even one isolated incident can significantly impact your brand and impact your brand value and brand perception. So that is another area that can happen. And then obviously the fourth one I already touched on was brand damage, especially in sectors like e-commerce, travel, and fintech, where the brand loyalty is still at an evolving phase, and customers, based on isolated incidences, can leave your brand for good. And plus, even small fraud events have this multiplier effect, and they are not just operational costs, they are strategic threats to your brand, your loyalty, and long-term viability. So the point I'm trying to make is these numbers are a wake-up call, but more importantly, they reveal a pattern. One, fraud is rising. Secondly, it is becoming more intelligent. And thirdly, the cost of inaction is not just financial, it's reputational, regulatory, and existential for some businesses. So from being just a matter of a fraud team sitting in one corner of the office or a compliance team working somewhere remotely, it's definitely a topic which has become a boardroom level discussion now, and hence the importance of this talk. Having painted that picture, let me jump to having painted the picture of, okay, fraud detection is important. Is AI-powered fraud detection the first time we have tried to figure out fraud in payments? No, there have been traditional methods which have always existed. So historically, they have used static filters, which are hard-coded logic like, if the transaction is over $5,000 and outside the customer's country, flag it. The rationale is simple behind using such logic. It appeals to common sense, but the reality is that it is slow, it is reactive, and increasingly ineffective. Let's unpack the key challenges these systems face today. So number one, I think I have already made a strong case on this. Digital payments are growing exponentially. I think the brick and mortar store are on the decline, and more transactions are being done online. So that is creating more and more transactions. It's no longer possible for human reviewers to manually vet flagged transactions. Even automated rules struggle to keep pace with the speed the market is evolving and growing. Plus, furthermore, fraud tactics, like I said, are evolving and improving. There are people who create synthetic identities, perform account takeovers, and mimic legitimate user behavior with high accuracy. Rules simply can't catch up with what they have not seen before. Hence, the need for real-time detection. Time is money, quite literally. If fraud is detected too late, the funds are often already gone. Traditional methods, which I talked about, which are basically heuristics, lead to delays which not just have financial losses, but also cause reputational damage and customer churn. So the point being, how do we fight back? That's where AI steps up and comes in the equation. AI systems don't rely on fixed logic. They learn from historical data. They can adapt to changing fraud patterns and predict the likelihood of a transaction being fraudulent, all in real time. Imagine a machine learning model that monitors hundreds of variables per transaction, so ranging from your IP address, your purchase history, and even behavioral biometrics. Unlike rule-based systems, AI models can continually evolve. Plus, they can be trained on new fraud patterns as they emerge, giving organizations using AI in their fraud detection mechanism can have significant competitive advantage and compliance as compared to companies or businesses who are not. So hence the strong need for companies to develop a sound and robust fraud detection mechanism within their operations. Now, coming to what exactly does AI bring to the table? The first standout feature is the higher accuracy. AI identifies patterns that humans and static rules miss, so definitely an advantage there. Reduce false positives. Instead of blocking legitimate customers, AI adapts to behavior, minimizing friction and increasing trust. I think this point cannot be made more stronger on the false positives, which is basically if you swipe a card somewhere when you want to make a transaction and the system either rejects you even though you are the legitimate owner of the card, it causes frustration and potentially leads to churn for the brand. So although on one hand it's important to catch the negatives, but false positives also erode customer trust and potentially lead to less retention as well. So it's a very fine balancing act that companies need to achieve in order to ensure compliance and also at the same time customer satisfaction. The third point is scalability. AI models continuously improve as more data flows through them. They can stay one step ahead of fraudsters in that sense. Now, having painted the picture of comparison of traditional methods versus AI, I put together a table just to give you a rundown on exactly what the traditional methods can do and why AI-powered methods offer significant advantages over the traditional methods. So the very first aspect is the approach, which is in the traditional method, it would have been rule-based. So you would have had a hard-coded threshold or a heuristic. So for example, a transaction being more than $500 or $1,000 being performed at an odd time. So those sort of heuristics would have given you an idea if the transaction is legit or potentially fraudulent. Whereas in machine learning, you can have decision trees, you can have neural networks, so you can work on anomalies, you can work on predictive modeling. So those are the sort of advantages AI offers in terms of approach. The second is flexibility. As you can imagine, with the traditional method, you needed, say, 10 to 100 or 1,000 of manually written rules on how to capture or how to identify a fraudulent transaction. Whereas in case of AI, you have models that can adapt and retrain. So you have that additional flexibility in them. And I think tied to this is the scalability. If you want to scale a traditional method, you have to have limited volume of information. So that is a constraint that you have. And then whereas in AI, you have excellent real-time and high volume handling that is possible in terms of scalability. And the point I made earlier in the earlier slides, e-commerce and transactions are increasing at a breakneck speed. So the fact that you can scale quickly is definitely an advantage AI offers. The fourth is detection speed, whereas old methods were more prone to being more slow and faulty. AI-powered systems can be real-time, so before and during transaction. So this is a significant advantage because imagine you are stuck at a supermarket and you swipe your card and the card takes 3 to 4 minutes for the transaction to go through. In today's day and age, this is an absolute no-go. And I think this is where AI-powered methods can be quicker in terms of compute and hence deliver better customer satisfaction. Accuracy, I think I already made the point that traditional methods were prone to high false positives because even legit customers would get flagged because their transaction raised a flag on one of the heuristics defined in the logic. Whereas in case of AI-powered methods, the optimization parameter is to have lower false positives. So identify what is normal and what is suspicious behavior. So this is another advantage that AI-powered methods offer. Detection of new fraud is also something which traditional methods were poor or slow to catch up to, whereas in case of AI, it is more robust and more fast in terms of capturing novel patterns via anomalies, which I would get to in a later slide on what anomaly detection is. Transparency is potentially an area where the comparison between traditional method and AI-powered method is tilted in terms of power balance, whereas because in the traditional method, it was very clear to identify what criterion did the logic use or the algorithm use to basically decide or to accept or reject a transfer or transaction. But whereas in the AI-powered methods, they can be opaque, as in lack visibility, which can potentially lead to claims of discrimination. So that is another area which is potentially weak at the moment. Implementation, I think, is obvious. the heuristic method is quick to set up, but very hard to scale. Whereas in case of AI-powered methods, initially they might need investment. You would need to have dedicated resources. You need to have skilled people who understand the ins and outs of the tool. But once you have that bridge crossed, you would have a technology that scales very well. And from the maintenance standpoint, again, it's in favor of AI-powered methods because they require lower maintenance and they have adaptive models. So one, you can really create potentially an autonomous system once you have set up the basic parameters. So overall efficiency-wise, again, AI-powered methods win out. They're more dynamic, adaptive, and efficient at scale. So overall, in the table, I put down 10 aspects to compare the two methods, and as you can see, around eight and a half aspects, AI-powered methods win out. The only major question mark would be on transparency. I think over time that would improve as well to provide visibility on more visibility on why a transaction was accepted or rejected. So that is the missing link I feel at the moment for AI-powered methods when it comes to transactions. Moving on, let's take a deeper dive into the core AI techniques that power intelligent fraud detection systems. So these three are the fundamental approaches that happen or exist in the backend once you pursue or do a transaction. Starting off with anomaly detection. Anomaly detection is exactly what it sounds like, identifying behaviors or events that are statistically unusual compared to historical norms. For example, if a customer typically makes small purchases and suddenly initiates a $2,000 transaction from a foreign IP address at 3 a.m., so that would raise a flag. AI models can detect these anomalies in real time, even when the transaction looks legitimate on the surface. So what technique is basically powering anomaly detection? So most of these systems are using unsupervised learning, for example, clustering or autoencoders, which don't need labeled fraud data. They simply learn what normal behavior looks like and flag deviations. Key benefit is that it is extremely useful for zero-day fraud, and which zero-day fraud means where patterns haven't been seen before, which traditional systems struggle with. The second is predictive modeling, which is number to the left on the slide you are seeing, which is using historical transaction data to estimate the likelihood that a transaction is fraudulent. Here we use supervised learning algorithms such as logistic regression, random forests, gradient boosting, or even neural networks. Each transaction is analyzed across a wide range of features. So for example, time of transaction, what was the transaction amount, what was the merchant category, what was the device type from which the transaction was made, the velocity, which is how many transactions were made in the past 1 hour. The model outputs a probability score, for example, 0.91, which is 91% chance of fraud. So based on that threshold, the system can then auto-decline the transaction. 1, or 2, it can flag it for manual review, or 3, it can require additional verification like OTP or biometrics. So all these 3 layers of protection allows businesses to balance security and user experience by not being overly aggressive with false positives. The third technique is pattern recognition, which I think is very sophisticated. Is basically where AI identifies complex, sequential, or relational patterns that indicate fraud. Think of fraud as not just individual transactions, but sequence of actions. A login from one country, a password reset 3 times later, a high-value transfer to an unknown recipient whom you have never sent money before. On their own, these actions might not look suspicious, but together they represent a fraud signature. So deep learning models, particularly recurrent neural networks, RNNs, graph neural networks, GNNs, are highly effective here. They learn from user behavior over time and spot subtle fraud strategies like account takeovers or synthetic identity creation. Pattern recognition also helps uncover collaborative fraud, where multiple users or merchants are part of a coordinated fraud ring. Key insight is that, in summary, anomaly detection helps uncover known or emerging fraud patterns. Predictive modeling provides real-time fraud scoring based on historical behavior, and pattern recognition captures multi-step dynamic fraud strategies that evolve over time, and hence my take that they represent a very sophisticated mode of identifying fraud. These three techniques are not mutually exclusive. In fact, I would say the best fraud detection engines today combine all three, creating a layered AI defense system that can adapt to changing attack vectors at scale. So now diving deep into some of the tools that I mentioned, I think the number one I would discuss is deep learning. And again, this takes fraud detection to another level. It is used to detect subtle, complex anomalies, the kind of behavior that mimics real users. For example, deep neural networks can analyze dozens of data points per transaction. So for example, the IP address, the device fingerprint, the purchase history, the time of day, and features of the like. So tools that can be used are TensorFlow, PyTorch, and platforms like H2O.ai are widely used to develop and deploy these models at scale and can be a good starting point if you are learning the topic. Now, coming to what about fraud that comes through text-based channels, having discussed earlier data on transactions. So text-based channels support, so for example, coming through chat, emails, or loan applications. That's where natural language processing, often called NLP, steps in and shines. They can detect linguistic patterns associated with fraudulent intent. For example, phishing emails, fake customer disputes, or manipulated application data. Tools like Spacey GPT models and cloud services like AWS Comprehend or Google NLP are increasingly used for these applications and provide robust mechanisms against fraud. Finally, let's talk about predictive analytics. These systems generate fraud risk scores in real time based on historical data and transaction behavior. For example, a transaction might get a score of 0.87, meaning there's a 87% probability that it is fraudulent, and that triggers an automatic hold for further review. Platforms like DataRobot, Amazon Fraud Detector, and FICO Falcon are leading the charge in this category. And again, good starting points for someone starting their journey in the area. Now let's look all of this, the whole talk in action. I think everyone on the call, or mostly people would be familiar with Visa, which is basically a payment network which powers your credit card or even your debit card. So let's look at an example of a real world application where they used AI-powered scam detection initiative that they undertook. As part of the project, they disrupted over $350 million in money in fraud, including 12,000 scam merchant sites linked to dating app con jobs. They prevented over $27 million in losses for potential victims. So how did they do it? AI models analyzed vast data sets from merchant behavior, customer activity, and third-party data. They worked with law enforcement to take down fraud networks that were identified basis flagging from the AI detection systems. And then they also used automation to help scale their scam detection workflows at a global level. And through all of this, they were able to realize significant savings, $350 million, through basically capturing and detecting customer fraud. So hence again, compliance driving customer trust as well. Now, taking a closer look, on the previous slide, I have a video which I think the organizers will make it possible for this slide deck to be shared. The link that you see would be there. It's a great, again, on the topic which I already said, it's a great video which Visa has put on, and it's available on YouTube. I will not be playing the video, but I will take you through what happens when, how does AI fraud detection work with Visa, for example. So let's take a closer look. It all starts at the moment you tap in or swipe your card and enter your card details. When a transaction is initiated, say at a store or online, Visa's system instantly springs into action. VisaNet, the global network that processes these transactions, collects hundreds of data points about the transaction. Things like the amount, the time, the location, the type of merchant, and more. As these data points travel through VisaNet, an advanced AI model analyzes them in real time. The system checks for over 500 unique risk attributes. Think of these as clues, each of them helping to paint a picture of whether this transaction is typical or suspicious. For example, is this a contactless payment or is it a chip card payment? Has this card been used at this merchant before or not? Is the purchase happening at 2 a.m. in a different country? Even small details in this context matter, like the device used or the purchase category. All this information is processed instantly to generate a risk score ranging from 1 to 99. A score of 1 means it's very likely a safe transaction, whereas a score closer to 99 indicates a higher risk of fraud. This score itself is not a decision, but it's a powerful signal. Visa then passes this information back to the cardholder's issuing bank within milliseconds. It's the bank's role now to make the final call, either to approve or decline, basis the feedback from Visa on what they think in terms of risk for the transaction. This decision happens so quickly that we, as users of Visa cards, do not really notice it at the shop or at the supermarket or at wherever we are making the transaction. But this is the tech that is happening in the background. And all of this happens in split seconds, where AI has assessed hundreds of variables and flagged potential fraud all before we even realize. So Visa's AI models is a model that continuously evolves on fraud patterns and feedback from banks and real-time outcomes. This adaptive learning helps reduce false declines, meaning fewer legitimate transactions are blocked, while staying ahead of fraudsters using more and more sophisticated tactics. In summary, Visa's AI-powered fraud detection system is a real-time intelligent shield that processes thousands of transactions every second. It keeps global e-commerce safe, frictionless, and fast. So over time, just to give you an idea of how the card evolution journey happens, over time, Visa develops your profile based on your card usage. For example, time, frequency, amount, and things and patterns of the sort. So over time, it generates lots of information on you for every transaction that you make. So for those of you who are concerned about privacy, Visa does not see your name or does not see exactly what product did you buy, but it does see what product or what category does the product that you bought, what category does it belong in. So that data point is collected every time you make a transaction. And then from the data, it compares you with 3 billion other accounts and 180 billion account transactions annually, giving it data points to learn and adapt. And then what does it do after it has identified patterns in your purchasing? So then it basically collates and clusters you in a group like this. So starting from the left on top, so are you someone who travels to London every quarter? So if you do, the next time Visa you make a transaction, it would automatically give you a very low risk score because it would know that you normally travel to London every quarter. If you eat out on weekends, the next time you swipe your card at an eatery outside on a weekend, it would potentially give you a low risk score. If you are someone who fuels up after work, the car after work, so it would know that around 6 p.m. on weekdays, you might be fueling up. So again, your risk score would be low in that case. If you're someone who pays for the subway with a mobile app, the next time you swipe your card at a subway, it would most probably deem that it's a genuine transaction. And all these factors on the right hand side as well are areas how Visa develops a clustering to know what patterns do people fit in. And then the next time you make a transaction, Visa is in a good position to make an informed or considered decision on whether this transaction is legitimate or is potentially fraud, and then flag it to your bank with whom the final decision rests. So having discussed all of this, the next time you use your card, think of all the backend tech that is happening behind the scenes and appreciate what AI is enabling for this. So in the past 2 minutes, the time I have been speaking about Visa, Visa has processed over 0.6 million transactions in the 2 minutes I've been speaking on Visa. So this is the scale at which Visa is operating and the scale at which e-commerce is operating in general. So finally, coming to the final slide, if you were to take one takeaway from this talk, it is AI isn't just an upgrade, it's a necessity in the modern day fraud fighting arsenal. As payment systems evolve, so must the methods to protect them. So if you're interested in a career in finance and tech, a career in fraud detection using AI can be very rewarding. So I would highly encourage people interested to reach out and potentially connect on LinkedIn. Happy to answer any questions now. I hope you've had a good conference day so far, and wishing you a further 2 productive days in the conference as well. Let me see. Are there any questions? I would stick around for 5 minutes and see if there are any questions. If not, I would close the call. Akram, are there any questions which you see? Oh, there are. Okay. Akram, I cannot hear you. Can you hear me? Okay. For some reason, I cannot hear you. Okay, I will take the question that someone has left. Can't we embed LLMs to provide explainability? Absolutely, absolutely. So this is an evolving field which definitely needs further work. But yes, LLMs can be a solution towards explainability. But then again, there are still several features or lots of nitty-gritties that still need resolution before we are at a stage where we can rule out any sort of discrimination in acceptance or rejections of transactions. Perfect. So if there are no more questions, I would leave it to Akram to take over. I think I don't know if everyone else can hear Akram. I cannot. So Akram, thanks a lot, and then thank you all. Like I said, yeah, I hope you have a nice 2 days in the conference and learn a lot. And then yeah, like I said, please feel free to connect on LinkedIn. Leave me a message. Just call out that you saw me here so that I know that you were here at the conference, and then I can add you. Thank you.